Hi, math fans. Okay, so we're talking about special products. When we multiply two binomials, there are some cases of multiplying binomials that make it easier to multiply because we know what to expect. So we already know the product of two binomials equals a trinomial. But there's some cases when multiplying two binomials will result in another binomial, and we're going to go through and explore some of those cases. Okay, so the first case is if I have a pair of binomials that have the same constant, but one's positive and one's negative. So I have x plus 3 times x minus 3. So we're going to use the distributive property on this, and I'm going to say x times x equals x squared, and x times negative 3 equals negative 3x. And then I come down here and use the 3. 3 times x is 3x. Use the 3 again. 3 times negative 3 is negative 9. So when I go to combine my like terms, what happens with the negative 3x and the positive 3x? Well, they're opposites, so they cancel out. So I'm left with x squared minus 9. Now, this will only happen if you have the same constant, but one's negative, one's positive, okay? And then basically all we're doing is we're squaring this, we're multiplying our x's, and we're multiplying our constants because those middle terms are automatically going to cancel each other out. So here's just another one to prove to you I'm not lying. If I had x plus 23, and you know what? It doesn't matter which one comes first. I could have x minus 23 times x plus 23. I know that I'm multiplying the x's. I'm going to get x squared. I know if I have one negative 23 and a positive 23, those are going to cancel out. I'm not even going to bother doing that. I'm just going to multiply negative 23 times 23. And I know that 23 squared is 529. I know everybody knows that because I asked you to memorize the first 25 perfect squares at the beginning of the year. And we all memorized them, right? So you had that at the top of your head? That's your binomial. Okay, so that's one special case when I have, and we call that x plus a times x minus a. They're just opposites, and they're going to give us x squared minus a squared. Okay, so that's one example. Another situation that you might encounter is if you get a binomial and they just say x plus 7 squared. Well, whenever we square something, that means you multiply it by itself that many, well, 2 times. So here I'm getting x plus 7 times x plus 7. So it sort of looks similar to what we just did, but this time both signs are the same, so it's going to be a little different. When I go to, and I'm going to use the area model, I multiply x times x and I get x squared. X times 7 is 7x. 7 times x, 7x. 7 times 7 is 49. So I'm looking at x squared. 7x plus 7x is 14x plus 49. So let's take a look at what we got as a product and what we started with. Do you see any correlations, any connections? I'm hoping you see that 7 times 7 is 49. And we know x times x is x squared. So that takes care of the first term and the last term. We know when we have x plus 7 squared, we're going to be squaring this, and we're going to be squaring that. Just joking. How did we wind up with 14x? Where does that come from? Well, we multiplied x times this 7 and got 7x, x times this 7 and got 7x. So basically what we did was we multiplied these two terms together, the x plus the 7, and we doubled it. So if I have a binomial squared, I'm going to square this term, I'm going to square this term, I'm going to multiply this and double it to get my middle term. So let's do another one so we can see that in real time. Let's use different color. If I had x minus 3 squared, I know I'm going to square this, and I'm going to get x squared here. I know I'm going to square negative 3, and negative 3 times negative 3 is positive 9. And then I'm going to multiply these together. Negative 3 times x is negative 3x, and I double it, and I get negative 6x in the middle. And that's how I can do that. I can predict, I know what's coming, so it makes it easier. I don't have to do the whole x minus 3 times x minus 3, squaring, multiplying, squaring. I can do a shortcut because I know I'm going to square this, multiply, and double. Okay, so that's another special case we have. And that looks like this. X plus a squared is going to give me x squared plus 2ax, because I multiply a and the x, and I double it, plus a squared. So that's your game plan for that binomial. And then I want to show you what happens when we have coefficients that aren't 1. So if I had 5x minus 2 times 5x plus 2, now remember, I have two opposites. So that means I'm going to square the first two terms. And again, I'm going to go back to the boxes because they never let me down. Five x times 5x is 25x squared. 5x minus 2 is negative 10x. 5x times 2 is positive 10x. 2 times negative 2 is negative 4. I can see right now these two are going to cancel each other out. So I'm looking at 25x squared minus 4. Okay, same process. I just have a number in front of the x now, and I have to not only multiply the coefficients, but the variables also. And here's one more. If I was given 7x plus 10 squared. So because it's the same binomial, that tells me I'm going to square that term, I'm going to square that term, I'm going to multiply these and double it. So 7x times 7x, 49x squared. 10 times 10 is 100. And when I multiply these two together, I get 70x times 2. And I get 140x. Okay? So that's all I got on multiplying special cases, special products. We're going to be revisiting special cases when we go to factor them. So if you have any questions, text me, email me, call me, do whatever you have to do to get in touch with me, but make sure I'm answering your questions if you have any. Go ahead and work on the Khan Academy videos, and I'll see you in the next video.